Hey everyone, welcome back to the channel.
Have you ever wondered what makes your toys zoom or your fan spin? It's fascinating to think about the tiny mechanisms that bring so much convenience and joy into our lives. The answer is electric motors. These small but mighty devices are the unsung heroes behind many of our everyday gadgets. These incredible inventions are everywhere, from your electric toothbrush that keeps your teeth clean, to the electric cars that are revolutionizing transportation and reducing our carbon footprint. They might seem complicated at first glance, but the basic idea is quite simple. Use electricity to create motion. This principle is the foundation of countless devices that make our lives easier and more efficient. Electric motors work by harnessing the power of two amazing forces, electricity and magnetism. When these forces interact, they create a spinning motion that can be used to perform a variety of tasks. These forces work together to create a spinning motion that powers countless devices we use every day. From the moment we wake up to the time we go to bed, electric motors are hard at work behind the scenes. Ready to learn more? Let's dive in. Understanding how electric motors work can give us a greater appreciation for the technology that powers our world. Without electric motors, our world would be a very different place. Imagine a day without the convenience of electric-powered devices. It would be like stepping back in time. Imagine a world without refrigerators to keep our food fresh, washing machines to clean our clothes, or even electric cars to get us from place to place efficiently and sustainably. These little machines truly power our modern lives. They are the backbone of our daily routines, making tasks easier, faster, and more efficient. So next time you use an electric device, take a moment to appreciate the tiny motor inside, working tirelessly to make your life better. Before we can understand electric motors, we need to understand a little bit about electricity. Electricity flows through paths called circuits. Think of a circuit like a racetrack for tiny particles called electrons. A simple circuit needs a power source, like a battery, and a path for the electrons to flow through, like a wire. When the circuit is complete, electrons zoom around the track, creating an electrical current. Circuits can be turned on and off using switches, just like a light switch in your house. By controlling the flow of electricity, we can control when and how our electric motors work. Now let's talk about magnets. Magnets are objects that create an invisible force called a magnetic field. This field can attract or repel certain metals like iron. Every magnet has two ends called poles, a north pole and a south pole. Here's the fun part. Opposite poles attract each other, while like poles push each other away. It's like a magnet dance. This push and pull of magnets is what makes them so useful. We use magnets to hold things up, store information on computer disks, and of course to power electric motors. What if we could turn a magnet on and off whenever we wanted? That's where electromagnets come in. An electromagnet is a special type of magnet created using electricity. To make an electromagnet, we wrap wire around a piece of iron like a nail. When electricity flows through the wire, it creates a magnetic field around the iron core, turning it into a magnet. The best part, we can control the strength of the electromagnet by changing the amount of electricity flowing through the wire. More electricity means a stronger magnet. Now, imagine combining the power of electromagnets with the spinning motion we want in a motor. To keep the motor spinning smoothly, we need a special part called a commutator. Think of the commutator as a rotating switch. It's a ring split into segments, each connected to the electromagnet inside the motor. As the motor spins, the commutator changes the direction of electricity flowing through the electromagnet. This clever switching action is important because it ensures that the electromagnet's poles are always interacting in a way that keeps the motor turning. Without the commutator, the motor would just get stuck. Section 6. Boosting motor power tips and tricks. Just like athletes train to get stronger, we can make electric motors more powerful too. One way is to use stronger magnets. Remember, stronger magnets create stronger magnetic fields, which means more power for our motor. We can also increase the number of turns of wire around the electromagnet. More turns mean a stronger magnetic field, just like adding more players to a tug-of-war team. Finally, we can increase the amount of electricity flowing through the wire. This gives the electromagnet more juice to work with, resulting in a more powerful motor. Section 7, inside a DC motor, a closer look. Now that we understand the key parts, let's put it all together and look inside a DC motor. A DC motor has two main parts, the stator and the rotor. The stator is the stationary part, usually containing permanent magnets. The rotor, also called the armature, is the part that rotates. It's basically an electromagnet mounted on an axle. When electricity flows through the rotor's electromagnet, it interacts with the stator's magnetic field, causing the rotor to spin. This spinning motion is what powers our devices. Section 8, electric motors, a symphony of science. Electric motors are one of the most remarkable inventions of modern engineering. They are everywhere, from the smallest gadgets to the largest industrial machines, quietly powering our world. From the simple principles of electricity and magnetism, we have harnessed the power of these fundamental forces to create something truly extraordinary. The interplay between electric currents and magnetic fields forms the basis of how electric motors operate. The clever design of the commutator, which ensures that the motor's rotation is smooth and continuous, is a testament to human ingenuity. Engineers have spent countless hours perfecting these designs, making motors more efficient and reliable. These tiny machines, powered by invisible forces, have revolutionized our world. They are the unsung heroes behind many of the conveniences we take for granted. From household appliances to industrial machinery, electric motors are integral to our daily lives. Understanding how electric motors work allows us to appreciate the wonders of science and engineering all around us. It opens our eyes to the incredible complexity and beauty of the technology that powers our modern world. Every time you turn on a fan, you are witnessing the marvel of electromagnetism in action. The motor inside the fan converts electrical energy into mechanical energy, creating the breeze that cools you down. Or when you drive an electric car, remember the amazing interplay of forces that makes it all possible. The electric motor in the car converts electrical energy from the battery into motion, propelling you forward with remarkable efficiency and power. The world of science is full of fascinating discoveries waiting to be made. Each new breakthrough builds on the knowledge of those who came before, pushing the boundaries of what we thought was possible. Keep asking questions, keep exploring, and who knows what amazing things you'll discover. The journey of scientific discovery is never-ending, and the potential for new innovations is limitless. Embrace the spirit of curiosity and wonder, and you too can be a part of this incredible symphony of science. Section 9. Keep exploring the world of science. Science is a vast and fascinating field that encompasses everything from the tiniest particles to the largest galaxies. It's a journey of discovery that never ends. Science is about asking questions and seeking answers. It's about curiosity and the desire to understand the world around us. Every question leads to new discoveries, and every answer opens up more questions. Electric motors are just one example of how scientific principles can be applied to create incredible technologies that benefit humanity. These motors power everything from household appliances to industrial machines, showcasing the practical applications of scientific knowledge. If you're curious about how things work, keep exploring. Curiosity is the driving force behind scientific discovery. Whether you're fascinated by the mechanics of a clock or the mysteries of the universe, there's always something new to learn. There are countless resources available to help you learn more about science, technology, engineering, and math, or STEM. From books and online courses to hands-on projects and experiments, the opportunities for learning are endless. Websites like Brilliant.org offer interactive courses and puzzles that make learning fun and engaging. These platforms provide a wealth of information and activities that can help you deepen your understanding of scientific concepts. Libraries are filled with books on every scientific topic imaginable. Whether you're interested in biology, chemistry, physics, or astronomy, you'll find a treasure trove of knowledge waiting for you. And don't forget the power of hands-on experimentation. Conducting experiments and building projects can provide a deeper understanding of scientific principles and ignite a lifelong passion for discovery. Remember, the world of science is your oyster. Science museums and exhibits offer a fantastic way to explore different fields and see real-world applications of scientific theories. So go out there and explore, whether it's a hike in nature, a visit to a science center, or a day at the museum. Every experience can teach you something new about the world. Who knows, maybe you'll be the one to invent the next world-changing technology. The possibilities are endless, and the future of science is in your hands. Keep asking questions, keep seeking answers, and keep exploring the world of science.
This video helpful? Don't forget to give it a thumbs up, subscribe to the channel, and hit that notification bell. Thanks for watching.